So before we start going over the review, I'm going to show you what your formula sheet's going to look like. It's not going to be the formula sheet that was attached to like the long review. We got rid of the formulas that you don't need, and then we're only giving you the ones that you do need. So I'll show you what formulas you're going to get. All right, so these are the formulas. It's a little dark, so if you need to move close to the board, you can see it. But here we have law of sines. This one is law of cosines. This is just the law of cosines to find the side length. We're also giving you the other one to find the angle too, but it's just not on this list, but that's one other formula that we're given. This is the area of a triangle. This one is the general formula for an arithmetic sequence. The one right below it is the arithmetic sum formula. Then we have geometric here. These two are geometric sums. The one on the left is finite. So this one is finite. The one on the right is infinite. So the infinite sum. And then the one at the bottom here is the angle between two vectors. So this isn't like every single formula that you need to know, because you do need to know how to find the dot product, you need to know how to find the magnitude, you need to know what to do with each of these formulas. But this is kind of any big formula that we gave you in the second semester that we've had, these are the ones that you're getting. The final is 45 questions, all multiple choice. All right, we're going to do a little bit of everything from the review. So starting with, let's do 23. So for 23, we don't have a pair. We don't have side A and angle A, or side C and angle C. So that means that we have to use law of cosines. If we don't have a pair, then we have to use law of cosines. So we're going to use our law of cosines formula here, because we're going to look for side C first. So even though this one says A squared, we're just going to substitute in for C squared. We're going to find C squared equals A squared, which is 25, plus B squared, which would be 12 squared, minus 2 times A times B times the cosine. So minus 2 times 25 times 12 times cosine of C. So cosine is 65. Make sure your calculator's in degrees, since we're talking about 65 degrees. When you put this in the calculator, your calculator needs to be degrees. So we have 25 squared plus 12 squared minus, and I'm going to put this all in parentheses, 2 times 25 times 12 times the cosine of 65. So we get C squared equals 515.4. We can take the square root of both sides. So the square root of this would be 22.7. Now units don't really matter here. It doesn't give us the units to begin with, but remember, it's just multiple choice. So you're just looking for the value. So look at your answer choices. Even just finding this, you may be able to use process of elimination and pick your answer choice without having to work out the entire question. We'll find the rest of it just to practice, but use your answer choices to help you. You may just be able to find one part of it and process of elimination with your answer choices, so you don't have to do the rest. So now that we have side C and angle C, we can use law of sines. So I can set up my proportion. I can say the sine of the angle, so 65, over the side, 22.7, is equal to, I'll find B next, sine of B over 12. So from here, I can multiply both sides by 12 to solve. Since I'm dividing by 12, I want to multiply to get it to cancel. And then I'm going to put this into the calculator. So I have 12 times the sine of 65 divided by 22.7. So we get 0.4791 is equal to the sine of B. Now this isn't our angle. This is what the sine of B is. So we have to do the inverse of this. So in the calculator, we're going to do that sine -1 button to find what angle B is. So when we do the inverse sine of 0.4791, you should get 28.6. So 28.6 is going to be angle B. Once we have two angles, we can add them together and subtract from 180. So I know that angle C is 65, and since angle B is 28.6, I can add those together. 28.6 plus 65, and subtract it from 180. So we get angle A is 86.4. So this would be what we're missing here, or three pieces of information: angle A, angle B, and side C. So keep in mind that if you have a side-side angle, you could have two triangles. So remember, you could have two triangles, you could have one triangle, or you could have no triangles. So side-side angle, you could have the possibility of these three things. This triangle, though, if I were to draw this out and I have A, B, C, and then opposite of angle A would be side A, opposite of angle B is side B, opposite of angle C is side C. I have C is 65, side A is 25, and side B is 12. This is not side-side angle. So we might think it might be at first because we have two sides and an angle that are given, but it's the included angle here. So this is actually side, angle, side. So we don't have to check for two triangles. But if you were given side, side, angle, make sure you check. Any questions here? All right, we'll do 14 to find the area of the triangle. So the area of a triangle formula is going to be given to you guys. That's this one. So our area is equal to 1/2 times A times B times sine of C. So times 120 times 74 times the sine of 100. So then we can just plug this into our calculator. So our area is going to be 4,372.5. Again, you don't have to worry about the units here because it's just multiple choice. So just look for your answer. Awesome. Let's do 39. So 39 gives us our vectors not in component form. It gives it to us in standard form. So we can rewrite it in component form because we like the look of it better. So we just take the coefficients. Whatever's in front of our I is going to be the first number. Whatever's in front of your J is the second number in your vector. So here we have 2, -1, and vector V would be 5, 3. So to find the magnitude of U, the magnitude is the square root of the first number squared plus the second number squared. So I'm just looking at vector U here, which is my first one. So we have 2 squared plus -1 squared, and the square root of that. So we have the square root of 4 plus 1, which would be the square root of 5. For B, we have the dot product. So dot product of u and v. Our dot product is the first number times the first number, so 2 times 5, plus the second number times the second number, -1 times 3. So this would give us 10 minus 3, so our dot product would be 7. Then for C, we have -2 times vector v minus 3 times u. So -2 times vector v, I'll write it out here. Vector v would be 5, 3, minus 3 times vector u, which is 2, -1. So we can distribute first. So this gives us -10, -6. Minus, here I'm just going to distribute the 3 first and leave it as a minus. If you wanted to distribute the -3, you could, and then change it to a plus. You could do that. But I'll leave it as a minus and only distribute the 3. So this would be 6, -3. When we subtract, be careful with the signs. -10 minus 6 would be -16. And -6 minus -3, that would turn into a plus, so that would be -3. Any questions here? Just for practice, let's look at 40. When we put this into component form, vector u would be 0, -6, and vector v would be 1, 1. Because we're taking the coefficients, and since vector u didn't have an I, we have to put a 0 in that spot. Next, let's look at 49. Here we're finding the component form. Component form is terminal minus initial. So it'll tell you which one's your terminal and which one's your initial. So we do terminal minus initial. So terminal minus initial would be 1 minus -8. So that would give us 9. And then terminal minus initial would be -5 minus 3, which would be -8. So this would be our component form for 49. Any questions here? All right, let's do 63. To find if it's parallel, orthogonal, or neither. Parallel, we need to set up a proportion. So our proportion would be the first number over the first number in the other vector has to be equal to the second number in our first vector over the second number in the second vector. So if they're proportional, they'd be parallel. To test and see if it's orthogonal, the dot product has to equal 0. And then if neither one of these are true, then it would be neither. So let's test and see if they're parallel first. So I could say 6 over 2 is equal to -1 over 5. If you don't see right off the bat that these are not the same, simplify it and then check. So 6 over 2 would be 3 is equal to -1 over 5. Does 3 equal -1/5? No, these are not the same. Next, let's test and see if they're orthogonal. Let's do the dot product. So the first times the first, 6 times 2. Plus the second times the second would be -1 times 5. 6 times 2 is 12. Minus 5 would be 7. Since our dot product does not give us 0, it's not orthogonal either. So our answer would be neither. It's not parallel and it's not orthogonal. 70, we want to find the angle between our two vectors. So we're going to go back to our formula up here. So the angle between two vectors is the cosine of theta equals the dot product over the magnitudes. Cosine of theta equals the dot product over the magnitude of u times the magnitude of v. So the three things we have to find before we can even plug them into our formula. We need to find the dot product. We need to find the magnitude of u and the magnitude of v. So our dot product is the first times the first, which would be 12, plus the second times the second. So 12 plus 5 would be 17. Then the magnitude of u is the square root of the first number squared plus the second number squared. So 3 squared plus 1 squared. This would be the square root of 9 plus 1, which would be the square root of 10. And then the magnitude of v, same thing, square root of the first number squared plus the second number squared. So the square root of 16 plus 25. Which would be the square root of 41. So let's plug these all in. Cosine of theta equals 17 over the square root of 10 times the square root of 41. We can plug this into our calculator. If you're going to plug it into the calculator all at once, make sure you use parentheses. So 17 divided by, I'm going to use parentheses, the square root of 10 times the square root of 41. So we should get cosine of theta equals 0.8395. It keeps going, but I'm going to leave this in the calculator. This is not our angle that we're looking for. This is cosine of the angle. So to find what our angle is, we have to do the inverse cosine. So that cosine -1 button in our calculator. So inverse cosine of this answer gives us theta equals 32.9 degrees. So let's look at the next page. We want to write the augmented matrix and solve. So to write our augmented matrix, I'll start row by row. So the first equation is going to be our first row. Remember, it goes x, y, then z. So we have 1, -4, -1, and then our answer would be 3. Then 2, -5, 1, 0, and 3, -3, 2, -1. What is the size of our augmented matrix here? Awesome. It is a 3 by 4. Remember, it's row by column. So we have 3 rows and 4 columns. To solve, when you have 3 equations with 3 variables, I would recommend taking your answer choices and plugging them in to see what works. It'll be quicker than solving this out. This is probably one of the most time-consuming questions. So take your answer choices and just plug them in. So let's say, hypothetically, if one of our answer choices was 1, 0, 4. 1 would be my x, 0 would be y, and 4 would be z. So I would take that and plug it into my first equation. So we have 1 minus, this turns into 0, minus 4. 1 minus 4 would be -3. Does -3 equal 3? Is this true? No, this is not true. So this would not be an answer. So because it doesn't work in the first equation, cross it off, move on to B, and check answer choice B. If it works in the first equation, make sure you check the second and the third because it has to work in all 3. So there could be an answer choice. There could be 2 answer choices that work in the first equation, but they're not both going to work in all of the equations. So if you get one that works in the first equation, make sure you check the other 2 as well. If it doesn't work in the first one, cross it off, go to the next. So this is a good example of a question where you want to use your answer choices to help you. Let's look at 4. We want to write the rule. So here, we want to see, is this an arithmetic or geometric sequence? What are we doing to get from one number to the next? Subtracting by 2. So that would make this an arithmetic sequence. Our arithmetic formula is a sub n equals a sub 1 plus n minus 1 times d. So a sub 1 is our first term. So we have 50 is our first term, plus n minus 1 times d. What's our d? What's the common difference? -2. The answer probably won't be written like this. It'll be simplified so we can distribute. So a sub n is equal to 50 minus 2n plus 2. So a sub n is equal to negative 2n plus 52. So this would be our rule. Let's say that this question asks us to find the 10th term. What could we do to find the 10th term? Plug 10 into n. Perfect. So a sub 10, our 10th term, would be negative 2 times 10 plus 52. So this would give us 32. So that would be our 10th term. So you can always check your work by, if let's say we wanted to check to make sure it worked out. Let's say we got this as our answer, but we just wanted to check. Or if we had no idea what to do to get our answer, we wanted to use our answer choices to help us, I could plug in 1, and when I plug in 1, you should get your first term. I could plug in 2 into whatever my formula is, and you should get the second term. You should plug in 3, and you'll get the third term. So you can check your work. You don't even have to really do the math here. If you're not sure what to do, use your answer choices to help you. Plug in numbers, see if it gives you the sequence in the question. So for number 6, let's see. I'm not sure if this is a geometric or an arithmetic sequence, but let's check. So we can do the second term divided by the first, 4 over 3 divided by 3 over 2. So keep change flip. 8 over 9. If we multiply by 8 over 9, does that give us the next term? No, it's not geometric or arithmetic. So we can't really work it out. You'll get either a geometric or an arithmetic sequence. This one's neither. But let's say all of our denominators were the same. I'll change this. Let's say all of our denominators were 2. So we had 3 over 2, 4 over 2, 5 over 2, 6 over 2. And we are just adding 1 over 2 each time. We could do it this way. So same thing, same formula. We have a sub n is equal to, our first term is 3 over 2, plus n minus 1 times d. What's d here? 1/2, perfect. So we would distribute. We get a over n is equal to 3 over 2 plus 1/2 n minus 1/2. So a over n is equal to 1/2 n. This would be 3 minus 1, which would be 2 over 2, so plus 1. You're welcome. Yeah, you'll get something that's a geometric or arithmetic. This one just happened to be neither. All right, let's take a look at 9. So 9 says simplify. If you want to simplify by hand, you can. Up top, we have 18 times 17 times 16, and so on. It keeps going down, but I'll call it 16 factorial. We'll just stop there. On the bottom, we have 20 times 19 times 18 times 17 times 16. It keeps going, but so does the top. So I can cancel out anything that I have in common. So I can cancel out the 18s, the 17s, the 16s, and everything after that. So I'm just left with 1 over 20 times 19. Then we can put this in the calculator. So 1 over 20 times 19 would be 1 over 380. Or 1 over 380 would simplify to 0.0026 depending on how your answer choices look. It might leave it as a fraction, it might leave it as a decimal. Remember, you can also put this into your calculator by using the probability button. So you could do 18 factorial in your calculator. If you have questions on how to put that in your calculator, you can ask me at the end. But that probability button, I think in most calculators it's PRB, and then you can just scroll over to the exclamation point, which is going to be your factorial. Any questions here? Great. Skip 12. You won't have to do anything like that for simplifying. Let's look at 14. So 14 is asking us to find the sum. This symbol is our summation. So we want to start by plugging in 2. This is our starting number. And the number up top is our ending number. So we're going to plug in 2 to 5 and everything in between. So when I plug in 2, I have 4 times 2. Then when I plug in 3, I have 4 times 3. 4 times 4, and then 4 times 5. I stop at 5 because that's the number up top. That's where I'm going to end. So 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. So when we add all of these up together, since our summation means to add, we would get 56. If you had a question like 16 and you had fractions, just put all the fractions in your calculator. Add them all up in your calculator. If your answer choices were all fractions too, you can always just divide the answer choices and see which decimal matches your decimal. So if you're not getting a fraction like the answer choices, make your answer choices into decimals like your answer is. We'll do 23 next. These are about the same. So here, since it is an infinite sum, we're going to use our infinite geometric formula. So our infinite geometric formula is a sub 1 over 1 minus r. So to find our first term, we have to plug in the number in the bottom into our variable. So here we're plugging it into k. So we have 2 times 0.5 to the first power. So this would just be 2 times 0.5, which would be 1. And then r is always the number that has the exponent. So our r is just 0.5. So when I plug these in, I have a sub 1, which is 1 over 1 minus 0.5. That gives us 1 over 0.5. So if we put that in our calculator, we get 2. All right, next let's look at 73. So expand using Pascal's triangle. You guys have to know how to come up with Pascal's triangle. So remember, we start with a little triangle of ones. Then we add the two numbers above it. So it'd be 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And then here we're going to the fifth row. So 1, 5, 10, 10, 5, 1. So 1, 5, 10, 10, 5, 1. So we want to start with our first term. So a, and a is going to be to the fifth power, whatever our exponent is on the parentheses. So a to the fifth power, then we decrease from there. A to the fourth, a to the third, a to the second, a to the first, a to the power of 0. Remember, a to the power of 0, whatever it is to the power of 0 is just going to go away. You can put a line through it. It always disappears. Then we have negative 4b. So negative 4b, here we're going to start with the 0 power. Negative 4b to the power of 0, negative 4b to the power of 1, negative 4b to the power of 2, negative 4b to the power of 3, negative 4b to the power of 4, negative 4b to the power of 5. So we can cross off the power zeros. Then we're going to combine each column. So our first term is going to be a to the 5th power. Second term, we have minus 20, a to the 4th power, b to the 1st power. From this point, once you get 2 or 3 terms, look at your answer choices. You might even be able to pick the answer just doing half the question. So look at your answer choices, see if you can process of elimination with just doing this. You probably can figure out your answer just by having 2 or 3 terms. But let's do the next one. Here we have to be careful because we have to distribute the 2nd power. So this would be 16b squared. So we get plus 160, a to the 3rd power, b to the 2nd power. We need to distribute here too. So 4 to the 3rd power would be negative 64b to the 3rd power. So this would be minus 640 a to the 2nd power, b to the 3rd power. Then when we distribute here, this becomes positive 4 to the 4th power would be 256 times 5 would be 1,280 a b to the 4th power. And lastly, negative 4 to the 5th power when we distribute would be negative 1,024 b to the 5th power. So that would be our answer. Don't rush these type of questions. If you only did the first 3 terms, make sure you don't make a mistake and choose the wrong answer, because the answer choices most likely will have common mistakes in them. So just double check your work. If you're gonna only do a few terms and look at your answer choices and pick from there, make sure you are correct with the few terms that you do. So for permutation, order matters. Combinations, order does not matter. So an example of a permutation would be like if you're in a school play. Remember, there can't be 2 people that are the main characters. So the order matters of who's which position. Same if you're in a race. The order matters of who's first, who's second. So this is an example of a race. It says there's 12 bicyclists entered in a race, and how many different orders could the 12 bicyclists finish? So you can do a permutation and put it in your calculator. This would be 12p12, because we have 12 people total, and we're seeing how many ways those 12 people finish. So you can use the probability button in your calculator. So you'd have to put 12 first, go to the p, and then 12. And then equals, you should get 479,001,600. Another way that you could do this, which we did in class a few times, is we have 12 positions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 different people could finish in first place. But let's say Andres finishes in first place. He can't also be in second place, so then we would have how many possible options in second place? 11, perfect. And then we would just decrease from there. 10 in third place, 9 in fourth, then 8, 7, 6, 5, 4, 3, 2, 1. And you could multiply all these together, which would be the same thing as 12 factorial. So this would be an example of a permutation because the order matters. Andres couldn't be in first place and also in second place. Any questions here?
How do you do it on this calculator?
I'll show you at the end. But I think if you click on the PRB button,
Yeah. Okay, I see it.
yeah, then you should see it. All right, next let's look at our deck of cards questions. Here it says aces are low for 97. So if I were to draw out my deck of cards just to give us a visual, I've got 4 suits. We've got hearts, diamonds, spades, and clubs, something like this. And then each one has a king, queen, jack, then 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 1 being the ace. And it says aces are low, so that's how we know that ace is going to go below the 2. So if you want to write it out for each one, you can. On Notability right now, you could just copy and paste. But we know that they're all going to have these same king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2, ace. So looking at 97, it says, what's the probability that we pick a number less than 6 or a diamond? Remember, or means to add. So let's find out, how many numbers do we have less than 6? So less than 6 would be all of these. So we have 1, 2, 3, 4, 5, 6. 6 times 4, because we have 6 numbers less than 6 in each suit.
It says less than 6, and then 6 is included, or no?
It will be more specific on the tests, but we're going to say 6 or less. I guess less than 6 should be 5, but it'll be more specific on the test. So since we have 6 in each suit, 6 times 4 would be 24. Over 52 cards total. Then we want to see how many diamonds do we have. We want to count all of our diamonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We also knew that we had 13 because we can just divide our total amount of cards by 4. But we have 13 over 52. Then we have to make sure we subtract the overlap. So make sure you subtract the overlap here. Because the cards that are less than 6 and that are diamonds are being counted twice. These cards in here. Cards that are less than 6 and diamonds. So our overlap would be 6 over 52. So then when we add 24 plus 13, we get 37 minus 6, 31 over 52. Any questions here? All right, perfect. Let's look at 99. It says, given a bag of marbles, you draw without replacement. So that means we're going to pick a marble out and we put it on the table. We do not put it back in the bag. What is the probability that both marbles are green when we have 6 green, 7 yellow, 4 blue, and 5 red? So remember, for probability questions, it's what we want over the total. So we have 6 green marbles in our bag over the total amount of marbles, which would be 22 here. Yeah, 22. So I pick a green one out and I put it on the table because I'm going to assume that it's what we want. How many green marbles do we have left in the bag?
5.
We have 5. Over how many marbles total do we have left in the bag? 21, because we have one less because we put it on the table. When it says that both are green, if it says both or if it says neither, this is an and. I'm assuming that I pick a green one and another green one. And means that we multiply. So I'm going to multiply here. You can simplify before you multiply, or if you want to just simplify at the end. I'm going to simplify first, so we can divide these both by 3. We're left with 2 over 7. And then here we have 1 over 11. So 5 over 11. Oh, 5 over 77 would be our answer. Now remember, with probability, it could be a fraction, it could be a decimal. So just look at your answer choices. You might have to divide this to find the decimal version to match your answer. Yes?
Is or the only one that you add for?
Or you add. So So and we multiply or we add. So one more question I want to do with you guys that's not on the review is going to be a partial fraction decomposition. So I'm going to make one up here. Let's say we have 2x minus 4 over x squared plus x minus 6. So for partial fraction decomposition, first thing we want to do is factor our denominator. What are two factors of negative 6 that add to 1? 3 and negative 2. Perfect. So we have x plus 3 and x minus 2. So I'm going to set this up. We can say a over x plus 3 plus b over x minus 2. We always want to multiply by the missing denominator. So a is going to get multiplied by x minus 2. B is going to get multiplied by x plus 3. So then I'm going to write my whole numerator as an equation. So 2x minus 4 is equal to a times x minus 2 plus b times x plus 3. And then to figure out what we're going to plug into our x's, we would set our factors here equal to 0, or your denominators equal to 0. So we have x is equal to negative 3 and x is equal to 2. So we can plug negative 3 in first. So we get negative 6 minus 4 equals a times negative 5. When I plug it into the x plus 3, it's going to be 0, so that'll go away. One of them is always going to cancel out because you're only going to be solving for a or b at a time. So here you get negative 10 is equal to negative 5a. Divide both sides by negative 5. So a equals 2. Let's do the same thing, but next we're going to plug in 2 because 2 was also on our list here. So 2 times 2 would be 4 minus 4. I made these numbers up, so it's not going to work out, but it's fine. We'll just keep working. 4 minus 4, it's equal to, the a is going to cancel. We have b times 2 plus 3, so 5. 4 minus 4 would be 0, equals 5b divided by 5, b equals 0. Last thing we want to do is plug these into our fractions. So we have 2 over x plus 3 plus, I'm just going to keep it as 0 for now, but we know that 0 over a number would just be 0, but it's not going to be 0 for your answer. I made these numbers up. So 0 over x minus 2. So if it said to solve, we would have to work it out this way, all the way, find your a and b. If it just said to set up, we would leave it this way with a over and b over. So you may have a question on the test that says to set up. You don't have to solve it all the way. If it says to solve, make sure you solve it all the way. So make sure you read the directions. One more that I want to do with you guys, just to practice this. We're going to set it up. Let's say we had x plus 4 over x to the third power minus 6x squared plus 9x. So if we were to set this up, what should we do first? Awesome. We want to factor out the x. So we're left with x squared minus 6x plus 9. Then what? How would we factor? What are two factors of 9 that add to negative 6? Negative 3 and negative 3. So this would be x minus 3 and x minus 3. Now since we have two of them, this is like saying x times x minus 3 squared. So we would have to write this out as a over x plus b over x minus 3 plus c over x minus 3 squared. So this would be how we set it up. And then if we were to solve, you'd solve it the same way. Yes?
Why do you also have the last one squared?
So we always have to have, if we have, like let's say if we had x to the 4th power, then when we set this up, it would need to be a over x plus b over x squared plus c over x cubed plus. So you want each exponent that comes before it.